Hey guys, welcome back. Looking at AMC 10A 2022, problem number 21, which actually really is not that bad, depending on how you look at it, right? It's definitely a question where, you know, seeing it in a particular way makes it not nearly as hard. Um, Basically, okay, so we have a bowl is formed by attaching four regular hexagons of side one to a square of side one. The adjacent edges of the adjacent the edges of adjacent hexagons coincide as shown in the figure. What is the area of the octagon obtained by joining the top eight vertices of the four hexagons situated on the rim of the bowl? Okay. Basically asking what's the area of this top hexagon. So basically, like, I think the trick to solving this is to imagine that, like, this is actually trapezoidal frustrum, if I'm not mistaken, a square pyramid, right? The top kind of podium looking thing, right? And right, you're looking at that and say, like, okay, well, maybe we can imagine this as sort of being a trapezoidal frustrum and then just sort of chop off these little pyramids from the corners, right? Well, what do we know about this? Well, we know that each of the lengths of the hexagonal hexagons, um, if we took a and extended its meet in a regular hexagon, right, 120, right, which would be 60 degrees. Distance is one. We know this must be an equilateral triangle, so these distances is one, one, then this is one, right? One, right? Well, that means this whole thing is 3 by 3 because of the symmetry of the hexagons coming outward. We know that that top thing must be a square, so therefore, this Pythagorean theorem, each of these distances must be square root of 2. Of 1 root 2, right? And we just need to find the area of this octagon, right? Well, the easiest way to do that is to sort of extend it into a square, right? So look at the sort of 3 by 3, which would have a four-corner triangle. Oh, sorry, right? 1 by 1 triangle. This is 1, right? So you just have like this or 9. Sorry, let me draw that better. Right, 9 minus 2 or 7. Really not that hard if you kind of think about it. But again, it's all about the approach. Like, could you do a whole bunch of crazy geometry? Sure. And I think I did the first time I did this problem. It took me a little while to realize that, like, okay, well, just imagine sort of the trapezoidal frustrum and then imagine chopping off these sort of triple pyramids, right? These tetrahedrons, I guess, right? And then you notice that you have a square, and then these corners are basically you're taking a 3 by 3 square, and then you're chopping off corner squares each of length 1. So it's like 9 minus 4 times 1 half, right? So 9 minus 2 or 7. So the answer is B7. Okay, so hopefully that was helpful. All right, I'll see you for problem number 22 later.